28 फरवरी हर साल पूरे भारत देश में नेशनल साइंस डे के उपलक्ष्य में मनाया जाता है। इसका प्रमुख कारण ये है कि 28 फरवरी 1928 में प्रोफेसर C.V. रामन, जो भारत के एक महान वैज्ञानिक रहे, उन्होंने अपने रामन खोज की जो है वो घोषणा की और यह घोषणा करने के 2 साल उपरांत 1930 में उन्हें नोबेल पारितोषिक दिया गया। इतिहास में शायद ये बहुत कम समय ऐसे हुआ है कि इतने जल्दी नोबेल प्राइज के लिए उनका सिलेक्शन हुआ 2 साल में, वरना ऐसे कई खोज है जिसमें कई वर्ष जो है बीते जिसके लिए नोबेल पारितोषिक की घोषणा की गई। इसमें उन्होंने जो उपकरण बनाया था रामन इफेक्ट में, ये पूरा इंडिजिनस था, पूरा भारतीय बनावट का था और ऐसे पता चलता है कि उस वक्त उसकी कीमत सिर्फ तकरीबन 200 रुपये थी। उनका विचार, उनकी विचारधारा यही थी कि विज्ञान जो है वो देश को और पूरे विश्व को जो है वो आगे ले जा सकता है। और इसी धारा को पकड़ते हुए भारत सरकार ने 1986 से यह नेशनल साइंस डे 28 फरवरी को मनाने के लिए शुरुआत की। IMD CRS पुणे, यहाँ पर भी इस साल नेशनल साइंस डे मनाया जाएगा। हालांकि हर IMD के कार्यालय में ये नेशनल साइंस डे मनाया जाता है। मंत्रालय, पृथ्वी विज्ञान मंत्रालय भी इसे मनाता है और माननीय मंत्री जी, उन्होंने भी एक घोषणा की है कि इस साल की जो थीम रहेगी वो इंटीग्रेटेड अप्रोच इन साइंस एंड टेक्नोलॉजी फॉर सस्टेनेबल डेवलपमेंट। तो हम सब चाहते हैं कि हम विज्ञान से जुड़े रहे, विज्ञान की पूजा हो, विज्ञान से जो विचार हमें मिलेंगे उसका हम सम्मान करेंगे। अभी जो अमृत महोत्सव चल रहा है उसमें एक बहुत बड़ा कार्यक्रम भी मंत्रालय ने और भारत सरकार ने किया है। उन्होंने भी यही घोषणा की है जो विज्ञान जो है उसको पूजा जाए और यह कार्यक्रम CRS पुणे में भी इस साल मनाया जाएगा। कुछ वीडियोस, कुछ पोस्टर्स और कुछ उपकरण के माध्यम से, YouTube के माध्यम से लोगों को, विद्यार्थियों को इसके बारे में जानकारी दी जाएगी और आने वाले समय में यह कार्यालय अपनी पूरा जोर लगा देगा जिससे विज्ञान की जो है वो प्रगति हो। विज्ञान जो है वो शहरों के लिए ही सीमित ना रहे, ये पूरे देश के जो है छोटे छोटे गांव में और छोटे छोटे जगह पर भी ये पहुंचे, क्योंकि IMD जो है वो पूरे भारत देश में है। रिमोटेस्ट प्लेसेस में भी IMD काम करता है। तो मैं समझता हूँ कि IMD इस नेशनल साइंस डे, जो भारत विज्ञान दिवस है, इसको उसी स्पिरिट में मनाया जाएगा जिस स्पिरिट में प्रोफेसर C.V. रामन साहब ने अपने दौर में काम किया है। जय हिंद।
The digital snow gauge, designed and developed by the Surface Instruments Division of IMD Pune, at its workshop, is India's first IMD-make digital snow gauge sensor. In January 2022, a team of IMD has successfully installed the snow gauge at Tawang in Arunachal Pradesh, which is at an elevation as high as 3,000 meters. The Pune Weather Life mobile app has been launched last year. In this project, around 35 automatic weather stations and automatic rain gauges were installed in and around Pune district at Ward Gaosheri, Magarpatta, Lavale, Chinchwa, Bhor, Kher, Girivan, Purandar, Ambegaon, Dond, Ballalwari, Indipur, Baramati, Junnar, Nimgiri, Talegaon, Shivaji Nagar, Rajguru Nagar, NDA, Haveli, Pashan, Malin, Shirur, etc., that gives the real-time temperature and rainfall data at those locations. Recently, many installations have been done by the Surface Instruments Division of CRS Pune at major international and domestic airports across India, including installation of present weather sensor at Hyderabad, Delhi, Jaipur airports to give precipitation, present weather, along with intensity of rain, water droplet size, etc. Wind sensors have also been installed at 10 meters height on frangible mast with the help of crane. Apart from this, ceilometers have been installed at 8 major airports across India. It gives 3 layers of cloud heights at the top of the ceilometer at touchdown zone of runway. In future, Met instruments at 18 international airports will be upgraded by IMD with state-of-art technology. Recently, the Office of Climate Research and Services has developed a climate data service portal with tools for generating various climate data products. This portal has several components for visualization of different products. The Mausam Vani for surface data displays the latest data from the surface observatories across the country. The Weather Now section displays the minimum temperature, maximum temperature, and 24 hours rainfall of the current day. It also generates a report if the top 5 extreme values of minimum temperature, maximum temperature, or 24 hours rainfall is crossed in any meteorological station in the country. The component Ritu Rang contains information on climatological normals and extremes. The surface normals section contains the graphical and tabular view of monthly, seasonal or annual mean, standard deviation, highest and lowest values of minimum temperature, maximum temperature and rainfall for stations and period, selected by the user. It also contains graphical and tabular information on monthly and seasonal rainfall for entire India, as well as for 4 homogeneous regions in the country, from 1901. Users can also view the All India mean seasonal and annual temperatures from 1901 onwards. The frequency of cyclonic systems in the Indian Ocean region from 1891 is also available in this portal. 10 extreme values of 24 hours rainfall, minimum temperatures and maximum temperatures for stations and month selected by the user can be seen under the extremes section here. The component Vivaranika is a one-stop display of metadata, latest data and the climatological information of stations selected by the users for the current month. This portal also contains free gridded temperature and rainfall data under the component Open Gridded Data. This office has a large repository of meteorological data, which is also supplied to users through the data supply portal. The latest version of the portal needs creation of user accounts by filling up the one-time registration form. Users can log into the portal and submit request for data by filling up the data request form. This new data supply portal has brought down the data delivery time to a couple of hours after completion of all formalities by the users. The Climate Data Service portal is upgraded regularly to add new products.
India Meteorological Department has prepared the Climate Hazard and Vulnerability Atlas of India for the 13 most hazardous meteorological events, which cause extensive damages, economic, human, and animal losses. This web atlas utilizes GIS tools and is available in IMD Pune website, www.imdpune.gov.in. The atlas provides information on 9 types of climate hazards, namely, wind hazard, extreme rainfall, lightning, dust storm, hailstorm, fog, drought, cyclone and thunderstorm, in terms of their spatial distribution of average number of days of occurrence, or probable extreme values. For example, in case of thunderstorm, this map shows the average number of thunderstorm days, on annual basis, for the period 1981 to 2010, over the various districts of India. More details will be displayed in the form of pop-ups when you scroll over the districts. Similarly, this map shows the normalized vulnerability index at district level for thunderstorms. Here we can see the districts which are less vulnerable, moderate vulnerable, high and very high vulnerable to thunderstorm events. The atlas also provides climate vulnerability information at district level on 5 types of hazards, namely, cold wave, heat wave, flood, lightning and snowfall. The districts are categorized as very high, high, medium, and low vulnerabilities for each of the climate hazards. These maps are prepared based on the disaster data from the annual publication of India Meteorological Department, Annual Disastrous Weather Reports, for the climate hazardous events that cause casualties in terms of death and other losses. For example, this map shows the total number of disastrous heat wave days in the month of May, during the period 1969 to 2019. Similarly, Normalized Vulnerability Index map depicts the districts which are less vulnerable, moderately vulnerable, high and very high vulnerable to heat wave events. Same types of maps and information are available for other events also. This figure shows the pie charts, representing the percentage of districts and population affected by disastrous weather events in different vulnerability categories. Here we can see 23% of the districts and 28% of the population are very highly vulnerable to the drought events. Similarly, 9% of the districts and 15% of the entire population are very highly vulnerable to the cold waves. Thus, the Hazard and Vulnerability Atlas can be used as reference point to issue impact-based forecast with respect to different weather hazards.
The Weather Forecasting Division of CRS Pune has recently launched a dedicated website for display of weather information of Pune, as well as various other CRS products. It contains the live automatic weather station and automatic rain gauge data of different locations in Pune, live weather forecast, and different other features. This website also has the Marathi version for the ease of understanding of the local people. Users can get the weather forecast of Pune for next 7 days, with maximum and minimum temperature and graphical display of weather parameters. It also has a crowdsourcing feature, where common public can contribute with their photos and videos of weather observed at their locations. Different weather reports prepared by the Weather Forecasting Division on daily basis can also be viewed in this website. You can also provide your feedback by filling up the feedback form. This website will be updated by the feedback received from different users. This office is planning to expand the location-specific forecast for major locations in and around Pune city in near future. The Climate Monitoring and Prediction Group at the Office of Climate Research and Services Pune continuously works to improve the climate monitoring and prediction activities over India, as well as for South Asia. In the year 2020, we have replaced the existing IMD normal dates of monsoon onset and withdrawal by the new normal dates of monsoon onset and progress based on the period 1961 to 2019, and that of withdrawal based on the period 1971 to 2019, for the operational services. As per the new normal, monsoon start its withdrawal from northwest India around the 17th of September, which is a delay of more than 2 weeks compared to the existing normal date, that is, the 1st of September. Monsoon withdraws from most parts of the country except South Peninsular and some parts of neighboring central India, by the 15th of October, coinciding with the existing normal dates of withdrawal. Recently, we have published monthly and annual climate summary for India, apart from the other climate monitoring products such as Climate Diagnostic Bulletin, Disaster Weather Events Report, etc. A daily district-wise gridded temperature data over India was also produced in addition to other datasets. Apart from the gridded data of temperature and rainfall over India, a gridded rainfall data for South Asia was also produced, and it is being updated regularly. This dataset is very useful for all the SASCOV member countries, in addition to their datasets. As per the demands from different users and government authorities for forecasts of spatial distribution of seasonal rainfall, our group has developed a multi-model ensemble forecasting system based on coupled global climate models. For the MME-based forecasts, coupled global climate models with the highest forecast skills over the Indian monsoon region, including our own MMCFS, have been used to generate the MME forecasts. Accordingly, the multi-model ensemble-based seasonal and monthly forecasts of southwest monsoon for the year 2021 were issued. Especially the spatial pattern introduced is the first time in the history of long-range forecasting of IMD. Operational monthly forecasts for the northeast monsoon season as well as winter season, using MME, were also recently started to issue. In the year 2021, southwest monsoon set in over Kerala on the 3rd of June against the normal date of the 1st of June, and southwest monsoon covered the entire country by the 13th of July. The withdrawal of southwest monsoon started on the 6th of October from Gujarat and Rajasthan region, against its normal on the 17th of September, and the southwest monsoon withdrew from entire country on the 25th of October 2021. At the end of the southwest monsoon season, the MME-based seasonal forecast was verified. Above normal rainfall observed over many parts of North India, Central India and Eastern Coastal India were matching with the forecast. Similarly, below normal rainfall observed over the extreme North India, some parts of Northeast India, also as per the issued forecast. However, the observed below normal rainfall over some parts of Northwest India and Central and adjoining East India could not be predicted. IMD Pune also acts as Regional Climate Center for South Asia RA2 region. Many activities like SASCOV and capacity building training are carried out under it. In connection with it, an objective forecast guideline of WMO, for preparation of South Asia Seasonal Climate Outlook Forum, was implemented.
The primary objective of Agricultural Meteorology Division, IMD Pune, is to strengthen the decision-making ability of farming community, to cope with the impact of adverse weather on crops, and to make best use of crop-weather relationships, to boost agricultural production. The Agromet Advisory Services provided under Grameen Krishi Mausam Seva Scheme, in collaboration with Indian Council of Agricultural Research, is a step towards reducing the weather-induced losses, by providing real-time information to farmers. This scheme is being implemented through 130 Agromet field units, located in state agricultural universities, ICAR institutes, IITs etc., and recently established 199 district Agromet units, located at Krishi Vigyan Kendras, under the network of ICAR. About 200 new agro AWS have been installed at newly established damus, to record real-time weather observations. These agro AWSs also have soil moisture and soil temperature sensors up to 1 meter depth, since these are very useful for decision-making and agricultural risk management. Apart from the conventional methods of agro-advisory dissemination, for example, TV, radio, mobile SMS, newspaper etc., IMD has developed a mobile app Meghdoot, in collaboration with IITM and ICRISAT, in which farmers can get information regarding the past weather forecast for next 5 days, along with Agromet advisories for their respective districts. Recently, these weather forecasts and advisory bulletins have also been integrated with the mobile apps of several state governments, such as Madhya Pradesh, Chhattisgarh, Tamil Nadu, etc. Furthermore, Agromet advisories in regional languages are directly being disseminated to the farming community, with the help of social media apps like WhatsApp, by AMFUs and DAMUs. Impact-based forecasts for agriculture are being issued during weather warnings which are detrimental to crops, along with possible measures for various districts in different states, as and when situation arises. The weather warnings for heavy rainfall, hailstorm, cold wave, frost, heat wave, high wind etc. at district level are issued by the concerned regional meteorological centers and meteorological centers of the respective states, and accordingly the appropriate district level advisories on farm operations to save the crops are prepared by AMFUs and DAMUs. The consolidated IBF is prepared by the RMCs and MCs of IMD and disseminated to the district collectors and agricultural officers of the concerned districts. These AMFUs and DAMUs also organize farmers' awareness programs at block and panchayat level in various parts of the country to popularize the service among the farming community, as well as to enhance the understanding of farmers regarding sensitivity of crops and livestock to weather. In the year 2021-22, total 1439 FAPs have been conducted till date across the country. During the FAPs, use of Meghdoot app to access weather forecast and Agromet advisories, and Damini app for nowcast on thunderstorm, lightning etc. are communicated. The feedback regarding the forecast and advisories are also being collected during these events, to improve our services further.